This is a Z80 Playground, and in this video I'm going to walk you through building one of these from a kit. So let's start by looking at the PCB. I'm going to call this the front of the board, where most of the writing is, and this the back of the board, where not so much writing is, and I'm going to call this side the top of the board and this the bottom, so it's basically it's writing side up. And you can see that there are various different chip sockets on here, and the convention that I've used is that all the horizontal chip sockets have their pin 1 at the left hand end, and it's marked actually where the chip number is, and all the vertically oriented chips or vertically oriented chip sockets have their pin 1 in the top left corner. So when we solder a socket on, the socket is going to have a little notch in the top of it. So if they're vertical, the notch is going to go up the top, and if they're horizontal, the notch is going to go over on the left. There are some components that have just 2 legs, such as an LED or a resistor. If they're polarized ones, such as some of the capacitors, then the plus and the minus is marked on where the capacitor is in most cases, and for the LEDs. Some of the components aren't polarized, but unfortunately I accidentally put polarized markings on anyway. So these capacitors here on the side, they're not actually polarized, but it does show a plus and a minus, but you can just ignore that. So what I'm going to do is I'm going to start by soldering it up so that we can get some power onto this thing, because once you've got some power going, you can check that the circuit's working a bit better as you go along. So the power is provided by the CH340 module, which plugs into these holes here. The only thing is that although the majority of the components go on the top of the board, this first thing goes on the bottom of the board, and it's going to go in here where these markings are. There's only really sockets that go on the bottom of the board, so you shouldn't be able to get anything confused. If you do put it on the top of the board, it will be a right pain to desolder it though, so let's get it right. What we need here is this 6-pin 90-degree bend connector, and this goes here. So what we're going to do is we're going to put the short pins in there, with the long pin sticking out to the side, and that goes underneath the board in this way. You want to really support it so they're at 90 degrees to the board. Is that about right? Yeah, that's about right. So we want to solder it like that. So the best way I've ever found of soldering anything that you want to keep in place is to use some blue tack. So I'm going to blue tack that up and solder it in place. So I've got my couple of pieces of blue tack. They're a bit hard, so I'm just going to squidge those up a little bit. And then where's the other one? There we go. And then I'll blue tack that in place. Let's make sure it's pressed down. There we are, and then I'll solder that on. I'm using my variable temperature soldering iron, which was pretty cheap off of Banggood, set at the temperature of 345. I think that's usually does quite well, and I've got, I think it's a 3mm soldering iron tip on there, but possibly a 2mm one would be better for this job, but we'll go with a 3mm one. And there's a reasonable amount of metal for this in this connector, and it's going into some of the pins that are ground pins or 5-volt pins, so it just needs a little bit of heat. And then this connector is going to be used to connect up the CH340 module, which provides the power for the board and provides the serial connector for the board. So once we have that in place, we can now plug in the CH340 module. But just a little note on these modules first. On them, they are configured in such a way that you can set them to either 3 volts or 5 volts with 3 little pads here. You can see here that I've got it set to 5 volts by soldering together the middle pad and the left hand pad. When you buy them, sometimes all 3 pads are completely blank, so you have to set it. Sometimes they're soldered to 5 and sometimes they're soldered to 3. So if your module is soldered to 3.3 volts, you're going to have to take the solder off and swap it over to 5 volts because we need 5 volts for this board. Also on this side, there is a similar kind of connector, solder jumper, which controls whether we get CTS or RTS coming out on this pin. One of the pins just here towards the end, I think it's the second one up. And we want CTS for hardware flow control. So if yours is set to RTS, you're going to have to desolder that, take the solder off that, and solder together the middle and the right hand pads. It's a bit of a pain, but it's just something you've got to do. Now on the back of the board it says which pins are which, so you've got your ground pin there, and on this module it says that you've got the ground pin at the top there. So that's going to go like that. Now, although that fits on there, there is a chance, there's a very slim chance of it bending down and short-circuiting onto the board, and also when you're plugging and unplugging, it's going to fall off. So what I've done is to use a little bit of a sticky pad to hold it in place and stop it from short-circuiting. What I think I'll do is put part of that padding on first, and then we've got to do a little bit more soldering, because we've got to use up these holes here. We've got to solder some components into these holes here before we put this in place, or else we're going to end up, we won't be able to get at them because we'll have put the module in place. So for now I'm going to use just half of one of these pads. I've cut one of these pads in half. I'm going to, if I can find the little peely bit, I'm going to peel off one side of it, and I'm going to stick that on to here. So that goes over there, so you can see why you've got to do that 5-volt connector first. Stick that over there, and that's just going to stop us from being able to accidentally short circuit anything, and that will come in handy in a second, as you'll see. So if I plug that in there, and then we connect up USB and 5 volts to there, we will have ground on this line here and 5 volts on this line here. Okay, so plug in the USB here. There isn't actually anything to see. There's no LED that comes on there when it's not doing anything, but we should be able to connect up a voltmeter, and we're hoping to see ground here and 5 volts there. So let's just try that. There are loads of places where you can grab 5 volts and ground off the board, so I'm going to grab ground off of there because that's nice and easy to get to, and I'm going to take 5 volts off of there. Oh, I've got my hand in the way, sorry. So that's, what have we got, 5.11 volts. And you should be able to pick up 5 volts at any of the places on the ICs. You can look this up on the schematic, or you can look at the chips, the data sheet of the chips on the internet. The chip names are all marked on the board, so you know which chip is going in which place. Most of them have 5 volts in the top right corner, which is sort of a convention. I think the Z80 is the only one that has its VCC in a crazy place. Where is it? It's just there, halfway down the chip on the left side for some reason. It's also worth mentioning at this point that you should see, if you've connected this up to your PC, you should see the CH340 module being registered in Device Manager as a serial port. Maybe it comes up as COM8 or something like that in your PC. So let's add a few components to make it a bit more interesting. Let's put on this, there's a big capacitor there to smooth the power supply, and there's a resistor for this power on LED. We'll use the power coming to this power on LED to look at the 5 resistors that you've got, and you can pick, they're all different colours, so you can pick which colour you like. I went for green for power, red for halt, white for the ROM to show that the ROM's activated, blue for the user, and yellow for the disk activity, but you can do whatever you like really. I've got my multimeter on its resistance measuring settings, so we can just take a look at this resistor. So this is the 1K resistor used to current limit. Yep, there it is, 1K. This is the current limiting resistor for the power on LED. You could actually use any value of resistance between about 0.5 K and 2K for that, because these 2mm LEDs are very bright, and if they're too bright for you, you might want to use a higher value resistor. But I've just provided 1Ks because it's quite a nice standard easy number. The LEDs are polarized. It's a polarized component, so you've got a long leg and a short leg. The long leg is always the positive, and the same applies for the capacitors, electrolytic capacitors. You've got a long leg, which is the positive, and if we can see that, yeah, so it says 47 microfarads, and the white strip with a minus in shows you that it's the negative lead, but you don't need to know that because you already know that the long lead is the positive one. So I will solder in that capacitor and that resistor, and then we'll have a little play around with the LEDs. And while I'm soldering it in, probably best to unplug from the power because we don't want any nasty things to happen. The way I've done these resistors is to mount them vertically so they take up a small amount of space on the board. I'm not sure if that was a particularly brilliant idea, but it means that what you've got to do is bend the resistor lead over like that, and then it's going to go into the board vertically, so it's going to be standing up like that on the board, in the same way that the capacitor is going to be standing up on the board, and the LEDs too. So let's put that in. So this goes in here. I've marked a big circle and a small dot, so you put the body of the resistor where the big circle is and the lead where the small dot is. Doesn't actually make any difference because it's not a polarized component, but probably just easier if you do that. And where the capacitors are, you've got a plus for the long lead, and the white mark on there matches the white mark on the capacitor, so can't really go wrong with that. A little bit of blue tack to hold it in place. Let's go like that. Turn it upside down and solder them on, and then clip the wires off. So once they're soldered on, the best thing to do, well, the only sensible thing to do really, is clip off the leads and keep those clip off bits somewhere safe, or else they are guaranteed to end up getting inside something and shorting it out. So I like to keep them somewhere, and the place that I like to keep them is on a magnet. So let's just make sure we got those. Now with those two components in place, if we plug the power back in, which is make sure you get ground to ground, trust me on that one. So plug ground in, we will now have power. So this is where we're going to put the power LED, and if we put an LED across that, we pick one at random, put it across, so the plus side goes to the long lead and put it in to connect it up. You can see that that's the yellow one, so I'm going to use that for the disc indicator. Let's check this one. That's the red one, so I'm going to use that for halt. This one I've got a feeling is blue because it's got longer legs. Yep, that's the blue one, so I'm going to use that for user. We've got there's the green one, so the green one's going to be for power, and so this one must be the white one. Yeah, that's the white one, so we're going to use that for the ROM power. So let's unplug power. I'll solder those in just so I don't lose the places on them, and then we'll see how that looks. Yeah, with those in and the power connected, we now get the power LED come on when it's connected into the PC. But we need to just put in 3 1K resistors in here, which are the current limiting resistors for those LEDs. And the reason we need to do that is just so that we can clear the space so we can then stick this on. So let me just put those 3 resistors in. With these 3 1K resistors in place, in fact I got carried away and did the 1K resistor for that LED as well. It now means that we can fix the CH340 module onto here. We don't have to worry about getting ourselves stuck by putting the module in, and then we won't be able to solder these afterwards. So this is how I do it. I'm not sure this is the absolute best way. This is going to go like that. I've put half a sticker on there. I'm going to put another sticker on top of there, and then I'm going to use another half a sticker, and I can then peel off one sticky side, push this in place and stick it down. I'll show you what that looks like. Yeah, so what I've done is half a sticky pad, one sticky pad, another half a sticky pad there on the end with the USB connector on. I've peeled the sticky side off of that, so if now that plugs into there like that, and then that sticks down there like that, that should be fixed on. If you can think of a better way to do it a better way, but that's the best way I've come up with. And that then means that you can pull off the USB connector without pulling the module off of the board and put it back in again. So let's see, that should get the power to come on and off. There we go, lovely. So the next stage is to make the clock circuit for the Z80. We're going to make a 10 megahertz clock. That's going to involve soldering in a 14-pin socket here. Remember, with the dip side of the socket, the dent side of the socket at the top, and a few other capacitors. So I'll solder that socket in first, because that's not a very exciting thing to watch, and then we'll put the rest of these components in so that we can get a 10 megahertz clock. For the oscillator circuit, we need capacitors 5 and 6, which are 8 picofarads capacitors, which are these tiny ceramic capacitors here, which have 8 written on them. And for the resistors part of the circuit, we need resistor 5 and 6, which is a 1M. 1M is brown, black, green, and 1K is brown, black, red. So that's those 2 resistors there. And you need the 10 megahertz crystal. Now, be absolutely certain that you get the 10 megahertz one, not the 7.3 megahertz one. So there we are, that's the 10 megahertz one. Crystals, it doesn't matter which way around that they go, actually. There's no polarity on the crystals on some of the boards. Some of these PCBs though, like this one, the crystal socket, or the crystal holes, don't quite match the pins on the crystal, and you'll end up with them slightly splayed, which is a little bit annoying, but well, I suppose it holds it in place while we're soldering it. So these capacitors go in here. They're not polarized, so that's 2 of those, and the resistors standing up go here, the 1M there and the 1K there. So I'll solder those on. So that brings us to our first IC, the 74HC14, which you can see here. Remember that it's going to have a notch at the top here, so it's going to go up this way in the circuit board. This is a hex inverter, a 6-way inverter, and it's going to go in the socket in the top right corner. And while we're putting it in that socket, we should put in the decoupling capacitor, which is here, a 104, which is capacitor 7, C7. This is a 104 ceramic capacitor, so it's not polarized. You can put it in either way around, despite what the PCB, the silk screen on the PCB might tell you. And 104 means 10 and 4 zeros, so 100,000 picofarads or 100 nanofarads. Okay, so we're ready to put the 74HC14 in place. And with some of these ICs, when you first get them, the legs are splayed outwards a little bit. We need to line them up so they fit into the sockets. So I find you quite often need to just lay them down on the side, squash the whole thing a little bit that way, turn it over, squash the whole thing a little bit that way, and get the legs so they're pointing straight down, or even sometimes pointing slightly inwards towards the bottom is the best. And check they're straight or it won't go in the socket. You should also probably touch something like a radiator before you deal with these kind of things, just to get rid of any static charge in your body, because you don't want static electricity destroying the chip, although I think these chips are pretty good at avoiding static. So remember that the notch on the IC socket is at this end, and the little dot on the IC and a notch as well to match is at this end. So that chip's going to go that way into the socket. If you put it in the other way around, I think it'll get hot and smoke will come out. So that goes in there. So let's put some power in and see what happens. Now, with power connected, I've got the power light on. I've got the ROM light on for some reason, but I think that that's just because we've got some pins floating. Because there you go. If I drag my finger around the bottom of that IC there, we can turn that on and off. So that's a bit naughty, leaving the pins floating momentarily, but I think we'll get away with it. But what we want to measure is there 10 megahertz coming out of our oscillator circuit? So I'm going to connect my voltmeter in frequency mode between ground and the Z80 clock pin, which is just here, and we're looking for 10 megahertz on there. And the meter says 10.01 megahertz, which, well, that could be my meter being slightly out, or it could be the crystal being slightly out. I bet it's my meter actually. Now, if you don't get 10 megahertz on the clock pin at this point, I would say most likely you might have your IC in up the wrong way. You might have bent one of the legs of the IC putting it in. You might have not soldered the crystal in properly. I've managed to do that before. Dry solder joint on the crystal will get you no clock at all. Or you might have got one of your values wrong, I suppose, in the circuit. But generally speaking, it's a pretty robust clock circuit, and you should get 10 megahertz out of that. A good step to do next would be to get the Z80 in and see if we can do something with that. So that's going to involve 2 of these 40-way sockets with a little notch at one end. So that's going to fit. One of them's going to go here for the Z80. One of them's going to go up here for the UART. A little bit tricky if the pins are slightly wonky, but we should be able to put one of those in and solder it up. And I quite like soldering these 40-way sockets. It always seems to be very, very easy soldering. So I'll do that now. And with those in place, I've also put a decoupling capacitor for the 16550 and a decoupling capacitor for the Z80 there. So they're 104s. They're just a 104 decoupling capacitor. That's on there. And it's worth, with this many solder joints, it's worth using some sort of magnifier to take a look underneath and see whether you missed any by accident or left any dry joints. Now, in order for the Z80 to function, we need to have a few other components in place. We've got to keep the reset line high, for example, and a few other bits and pieces. So we need 3 capacitors to do this. R14, which is up here, R13, which is just under here, and R15 over here. They're all 10K resistors. And then we're going to have to solder these switches in. So I'll put those 3 resistors in first, and then I'll talk about those switches. These are the first 10k resistors that we've soldered into the board so far. So it's worth pointing out that they're brown, black, orange. Now these 3 switches are technically speaking a surface mount component, but it's nothing to be scared of if you're not used to doing surface mount soldering, because they're particularly huge surface mount components. Most surface mount stuff is much smaller than this, but they just sit on top of the board with their 2 connectors lined up with the 2 solder pads underneath. And I think the best thing to do is just hold them in place with blue tack and run a little bit of solder, let a little bit of solder flow around either end. Here you can see that I've put the switch onto its position and I've fixed it down with a very small piece of blue tack, and it should be sitting nicely on the surface of the board with the 2 ends just touching the pads. And what I then want to do is get some solder and just flow it in. So I'm going to put the soldering iron. So what I want to do is put the soldering iron just onto the pad, so I'm touching the pad and just maybe the end of the switch, so it warms it up. Flow a bit of solder in there, and then turn it round and do the other side. And let's see whether I've done a good job. Well, perhaps a little bit too much solder used on that right hand one. Let me see if I can clean that up. Well, yeah, that'll do. It's not moving around and it's clicking fine. So, well, we'll test it in a second when I plug the Z80s in. So I'll do the other 2 and then we'll put the Z80 in and see what we can get to happen. Now this next stage is optional, but what I'm going to do is I'm going to solder in the 36-way header along the end here, and I'm going to then use that to be able to connect up to a solderless breadboard so I can see if the Z80 is running before I put the rest of the components in. Now, you don't have to do that, but I think it's a nice thing to do just to check that you've done a good job so far. So this connector obviously fits underneath the board with the short ends going through the board. I'm going to blue tack it up, and I'm going to probably solder the opposite ends on first, and then work my way along and solder the header on. Make sure it's pressed firmly up against the board and start soldering. And just for completeness, let's solder in 3 more 10k resistors. These go into R4, R10 and R9. There is also a resistor here which is labelled on some of the PCBs as 1K5, but the actual value for it is 1K2, and a 1K2 is one of these, which is brown, red, red. So let's solder that in. And then there are 2 capacitors, electrolytic capacitors, 10 microfarads and 1 microfarad, which are these 2 here. The 1 microfarad is actually, funnily enough, the bigger one of the 2. 10 microfarads is the smaller one. They are polarized, so you've got to get the positive, the long lead in where the plus is, and the short wire in where the minus is. Which means we've reached the point where we can put the Z80 itself in. So here's my Z80 CPU. The notch is on this end, so that's going to fit this way into the socket. It really is worth checking on these that all the pins are in a straight line, none of them are bent, and that they are curved in slightly. You can see one of them slightly wonky even there. And when we push it into the socket, we want to make sure that we don't bend the pins. So it's worth doing it very slowly and gently to make sure that you don't buckle one of them underneath. That's it. You know when it's gone fully down because you can feel it click right into place. So that should be sitting flush down with the socket. It's worth looking along, just check that none of the pins have actually popped out the side. Now onto the optional step that I mentioned earlier. I'm going to plug in the Z80 into a solderless breadboard just to see if the Z80 is running. I think that probably shouldn't need to do this, but I'm going to do it anyway. It's just a bit of fun really. So if we put that in there, what I'm going to do is connect up the ground to the top blue line there and the power to the red line. I've already checked on this breadboard, and blue runs all the way to the other end and red runs all the way to the other end. Some breadboards don't, which is a bit of a pain, but this one I know does. So we'll then have ground and power here, and then I'm going to connect up the data lines to fake myself a NOP instruction. So basically I'm going to connect up to all the data lines to ground to fake a 0 instruction, so we can make the Z80 think that it's running just a program filled with NOP instructions. In fact, it's occurred to me that it'd be better if I put it over there, slightly to the left, so I'm going to put some blue tack under there just so that we don't, because I haven't put the legs on yet. And let's connect up power. So we'll have from the VCC, we'll take that to the power, and from 0 volts, we'll take that to the ground. There we are. So we've got now along this end here, we can connect either to a 1 or a 1 on the red line and a 0 on the blue line. So let's get 8 wires. And so we need, for a NOP instruction, we need 8 zeros. So we'll start at D7 here, and we'll connect D7 to 0. We'll do them in batches of 4, shall we? So we'll go D7 0, D6 0, D4 to 0. I got it wrong, I was putting them on 1 for a start, but I've moved it over. And then D3 to 0, 2 to 0. So now if we power up by putting in the USB connector at the top, and I connect up my voltmeter in frequency mode, grab ground from a point maybe there, and we'll just look at the frequency of the clock pin first. So that's that one. So we've got 10 megahertz. And if we look at the M1 pin, so the M1 pin is showing 2.5 megahertz. So a quarter of the speed. Oh, that poor, shouldn't really leave that ROM light floating. We're running NOP instructions. A NOP instruction takes 4 clock cycles. So the M1 pin, which goes low for each instruction, is going low at 2.5 megahertz, a quarter of the clock speed, because it takes 4 clock cycles to do one instruction. Now what I want to do is change the instruction to a halt instruction. So that is 0111, so 0111, 0110. We can get that. If we get that right, we should see a halt instruction. Now there we go, it's already done it. So it's running a halt instruction, which is why the halt lights come on. If you hold down reset, the halt light will go off. When you let it go, let me check those wires. Well, I'm actually quite pleased that I did that little optional step, because I found some bad soldering that I'd done. So I've got it working now. All I did was I measured the voltage at all of the Z80 pins, and I found that 2 of them were at a slightly dubious voltage, not 5 volts or 0 volts. So I reflowed the solder on this header connector along here, and I pushed the Z80 more firmly into its socket, and one of those 2 things has fixed it. And if you get a problem with electronic circuits, 9 times out of 10 it's to do with connectors. So and I mean, this circuit works well, I know it works well, the PCB is very good quality, so the fault is always going to be with my soldering or connectors somewhere along the lines. So I'll show you the state that I've reached with it then. If we run the instruction 0111, 0110, which is a halt instruction, then if we reset, we come out of halt mode. When we let go of reset, we go back into halt mode, because it runs the halt instruction. And if we change, so that's 0111, 0110, which I think is 76 in hex. If we change it to 77, which I think is a load contents of HL with A instruction, so the CPU is going to run that instruction over and over again. We clear, when we press reset, we clear the halt state, and we carry on running as normal. And if I bring the multimeter in to measure the frequency, we've got a frequency of 1430 kilohertz when we're running that particular instruction. And having removed the board from the solderless breadboard, the next thing I want to do is check that the 16550 is getting a good clock signal, and that is done by these two capacitors here, C17 and C18, which are a 47 and 22 picofarads capacitor. Which are these two here, which you can just about see are marked 47 and 22, and they're not polarized, so you can put those in either way round. And of course, we're not going to get anywhere at all without the 7.3728 megahertz crystal oscillator. This is used for the timing for the 16550, and the reason for the strange number is because that gets divided down to make the exact baud rate that you need. And if by this point things are not going too well for your board, the Z80 isn't running, I think one good thing you could check is that all the pins that should be held high, such as reset and bus request, are actually being pulled high, and the pins you'd expect to be low are being pulled low. If they're not, then I suspect you're soldering, or you've put a component in, or you've missed a resistor off. Next on the list is the 16550, and these are particularly prone to having quite widely splayed legs, so I always find these need a little squidge down before they'll fit into the socket. And it's going to go into the socket here, obviously with the dip, the little indentation on the left hand side. And with the 16550 plugged in, we should be able to measure the frequency that that is running at. So between ground and the fifth pin up, 1, 2, 3, 4, 5, fifth pin up on the left hand side, we've got a frequency of 7.38 megahertz, so that's perfect. And that means it's mostly sockets left to do now. So we've got 3 14-pin sockets for the logic chips, the chips here, which are in charge of things like mapping the I/O ports, and then the 64K of RAM sits across here, and that goes in a quite an unusual shaped socket. So that would be a 32-pin socket, but I don't think they make 32-pin sockets, so we're going to solder in 2 16-pin sockets across there, which join up against each other nicely to make a 32-pin socket. And we just need to solder 5 more 104 decoupling capacitors in, one for each of the main chips that doesn't have a decoupling capacitor yet. This is the UM61512, which is the 64K of RAM, so that is going to go in here. This is the 74HC02, which is going to go in the bottom left corner, down here. And there are 2 74HC32s which go in the 2 remaining sockets. And there are these 2 3-way connectors which form jumpers, and they go into the board up in the top left corner. So put the short side in, the long side sticks out, and we're going to put one of the little jumpers on each one of these. These control whether the ROM is always on, or whether it's controlled by software, switched on and off by software. And they control whether the EEPROM occupies the bottom 16K or 32K of memory. So let's get those soldered in. Once you've soldered those on, you can attach the 2 jumpers. So these are going to set certain things on the Z80 Playground, and I think that the safest place to put them is to put switched on there, so the ROM is switched by software, which you'll have to do if you're going to use CPM, because CPM turns the ROM off after it's booted. And I usually put the other one on the 32K setting, so that the EEPROM takes up the bottom 32K of RAM. There are 2 sockets left to go, and they go underneath the board, so they need to be soldered onto the bottom here, and they're going to be the sockets that the CH376 module fits into. So let's get those soldered on next. With those 2 sockets soldered in place, it's time to push the CH376 module into those. It is going to either go very, very easily or very problematically, depending on how straight you soldered the sockets in. That one went quite well, actually. So as you can see, this is a version 4 module. I've tested all the modules. Some of them are version 3, some of them are version 4. The versions don't seem to make too much difference, but you'll see the version number come up on the screen when the Z80 Playground boots up. All that's missing now is the ZIF socket to put the EEPROM into. These sockets are unlocked when the arm is facing up, they're locked when the arm is facing down, and the socket is oriented such that pin 1 of the EEPROM goes here. So it could be a good idea to get a pen and mark on there pin 1, so you always remember to put the EEPROM in up the right way, because it is easy, and I've done it several times. You put the EEPROM in up the wrong way and it clears the contents of the EEPROM or makes the EEPROM smoke or some kind of problem like that. Now, another note about these is that this is probably the weakest link in the circuit in terms of connections, because everything else in the circuit is a solder connection, but these sockets are a physical connection. The pins of the EEPROM are clamped into them by pressing this down, and so I have had bad connections because the EEPROM legs have not quite registered in these sockets correctly. So if you get any problems at all, a very good place to start looking is in here. Are the legs, or are the holes in here lining up correctly? They should be closing on the legs, and are the legs of the EEPROM all straight and going into the right holes in here? And just a few final finishing touches really now. We need to put these 4 legs on. We need to plug the USB stick into there, and we need to put the EEPROM into its socket. So it's going to go up that way. This is pin 1, which goes over near the lever. Put that in there with the lever facing up. Press the lever down to lock it in. I'll put the legs on and we'll try it out. So even without Terraterm loaded up on my PC or anything, I'm just going to plug in the power and see what happens on the lights that flash on the Z80 Playground and look for the normal boot sequence. And yeah, that's actually good. So I'll just show you that again so you see what happens. The normal boot sequence you'll see is that there'll be some disk activity because the Z80 Playground looks for the UART config file when it boots up. There'll be some user activity because I made it flash the user lights just so you could see something was happening when it boots up. So let's go through that. Yeah, so you get some flashes on the disk and some flashes on user. The ROM light is on because ROM's enabled when we first come into the monitor, and the power light's on. So it's a shame. In a way, it's a shame it didn't fail, because you learn much more when things go wrong than when they go right. If it doesn't work, I would check that the EEPROM's in properly. I'd check all your chips are in properly. I would check that you've done your good soldering, and I would just have a general look around for solder bridges or any mistakes on the underside of the board. So if we switch to the Terraterm screen, you can see that we've booted into the monitor from the ROM, and actually there's a little bit going on that gets lost, scrolls off the top of the screen, but here it is. It starts up with Z80 Playground monitor with loader version 1.0. We look for the USB drive. We found that the module exists, and we found out that it's version CH376S version 4, as I already knew about that particular module. It then loads the config file, so the UART config file, and we've chosen the settings of 460/800 board and no flow control. Inside the monitor there are quite a few things to play around with, but the most interesting one I think is to start CPM by pressing C, and you can see that it has started up CPM version 2.2 and gone to the CPM prompt, and we can type dir, and there we go. So I find on mine, because this USB drive has a light in it, when you do some disk activity, it's going to flash the light, and it's going to flash the Z80 Playground's disk activity light, and you wouldn't expect to see any of the other lights come on. But if we go back to the monitor by pressing reset, we can actually try out those other lights, because I don't think we've seen the, well, we have seen the halt light come on, but we can test that by pressing hash, which will halt the CPU, so we'll have to reboot that. We can toggle on the user light, which we can do with U, toggle that on and off, and we can toggle the disk activity light on and off. So I think we've tested out all the facilities of it there, and it seems to be working fine. And just as an addendum, some of the kits have got this new type of 90-degree connector, which is slightly different to the previous ones, which I think gets the CH340 module a little bit more tight on the board. And if you've got one of those in your kit, then what I suggest you do is connect the CH340 module onto there already. Put it on the bottom of the PCB facing that way, and use a couple of pieces of blue tack just to hold that in place while we solder it. So with that there, and the connector kind of flush with the top there. I would solder along this side first, so solder from the underside with this type of connector, and then just fill in any solder that's missing in the connector on the other side. When you finish doing that, you should end up with the connector looking like that, so flush with almost flush with the surface, but just enough room to be able to pull the CH340 module off and stick it back on again. And on the top side of the board, you can see I've just finished those off with a nice bit of solder on the top too.